Okay, an ion. An ion is a charged atom, an atom that has more or less electrons than the number of protons. So, since protons are positive and electrons are negative, in most matter, we have the same number of protons and electrons. So if we have 10 protons, we have 10 electrons, and the overall charge on that material becomes 0. But sometimes atoms can lose or gain electrons, and when they do that, they become ions. So if for some reason, if we wanted a positive object, for example, let's say the atom lost an electron, then we would go plus 10, and he only had 9 electrons now. The resulting charge would be plus 1. If we wanted a negative object, here we would get extra electrons. Again, plus 10, but this time instead of our 10 electrons, let's say we're up to 11, we'd get a charge of negative 1. Note that the number of protons never changes. Protons are very heavy, they're located in the center of the atom, and so for those two reasons, they're much harder to take or remove from atoms. As a result, the number of protons in the atom remains pretty much fixed during any, well, not pretty much, it remains fixed during any chemical reactions. It would take a nuclear reaction to change the number of protons in an atom, and those are obviously a completely different thing that we're not talking about right now. So remember, when we have an ion, it's always more or less electrons, and the protons remains constant. So let's look at an example here. Let's say that I have the ion fluorine, and I'm going to make him -1. And I go to my periodic table and I see his atomic number is 9, and his atomic number is 19. What does that mean then? Well, remember, my atomic number gives me my number of protons, so that's 9. And my neutrons is equal to my atomic mass, the bigger one, minus the smaller one. And remember, you round that 19 if you have to. So I have 10 neutrons. And then when I go to figure out my electrons, before this, when I've been doing my Bohr-Rutherford diagrams, I've always just used the fact that it's neutral and said my protons is equal to my electrons. But this time I'm going to look a little bit more carefully and realize I have an ion, or I have a charge. My charge is -1, which means if I have 9 protons, I have 9 pluses, then how many electrons would I need to get up to a charge of -1? Well, -1 means that the electrons are winning, and they're winning by 1, so they must have scored 10, or there must be 10 of them. Or plus 9 minus 10 results in my charge of -1. So now I can make my Bohr-Rutherford diagram. I can put my protons in the center, my neutrons in my center, and then I can go in the first shell with 2 electrons. And then in the next shell, because I have 10 electrons, that means I still have 8 electrons to put. Note here that I now have my 10 because I'm following my 2, 8, 8 rule. And so the last thing I need to do for a Bohr-Rutherford diagram of an ion is I have to put big square brackets around it and put the charge on the outside of those big square brackets. So that's a negative ion. Let's look at a positive ion. Let's say calcium 2+. Actually, let's not do calcium. Let's do magnesium just because it's a little smaller, it'll be a little easier. So let's make magnesium +2. So here I have my protons at 12. And my neutrons, remember when I'm using this 24.3, I round it to just 24. Minus 12 gets me my neutrons at 12. And my electrons, here the positives have won. They've won by 2. So that means I must, if the positives scored 12 and they won by 2, the electrons must have just scored 10. Or my charge is plus 12 minus 10, leaving me with the plus 2 that I was looking for. The way this thing became positive, it's lost electrons. How many electrons did it lose? it lost 2 of them. Okay, so 12 protons, 12 neutrons, not 12.312. Can't have a 0.3 of a neutron. That, 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. That gets me my 10 electrons, so I stop. I don't make another shell. And my big square brackets, and I put 2 plus outside those big square brackets. So that is the Bohr-Rutherford diagram for magnesium when he has a charge of +2.